Hello, I'm Angie, Field Application Engineer from Moxa Australian team. Today, I'm going to introduce several network redundancy solutions, show you how simple it is to configure redundancy in Moxa switches, and how different protocols perform. Most electric utility networks are mission-critical, especially in substation automation. So they need to be reliable and fail over quickly. IEC 61850-5 suggests that SCADA to IED communication recovery should be less than 400 milliseconds. This can be achieved with ring topology-based redundancy, which provides predictable recovery time comparing to spanning tree protocols. In this video, I will demonstrate 3 redundancy protocols. 2 are Moxa proprietary, called Turbo Ring and Turbo Chain, and the other one is standardized, called MRP. To form a Turbo Ring version 2, the switches in the ring need to elect one switch as the ring master. The secondary port of the master is blocked to prevent looping. When the master detects a failure, it will unblock its secondary port to activate the backup path. The entire recovery time can be less than 20 milliseconds with a fast Ethernet link and 50 milliseconds with a gigabit Ethernet link in a single ring composed of 250 switches. I will use 2 modular DIN rail switches from MDS G4000 series to form Turbo Ring version 2. First, I will configure this switch and continue configuring the second switch on the right-hand side. The entire configuration of Moxa switches is done through Web User Interface. Now I'm logged into MDS G4020. To set up Turbo Ring, I need to navigate to Network Redundancy, Layer 2 Redundancy, and click Turbo Ring version 2. First, the protocol must be globally enabled. Then I need to configure Ring 1, enable it, decide whether I want this particular switch to be a master, and choose 2 ports that will be used to form the actual ring topology. I will use port 1/1 and 1/2. Finally, hit Apply to complete the configuration. I'm repeating the same steps on the second switch, where I also use port 1/1 and 1/2 to form the ring, but leave the master setting as disabled. Now, when the configuration is done, I can connect the cables to previously selected ports and create the ring topology. Once the connection is done, we should see master LED turning steady green on the ring master switch. If we navigate to Status tab in the Web User Interface, we can see that the ring is healthy and one of the ports is blocking. And this is how Turbo Ring version 2 is shown in Moxa Network Management System, called MXView1. This link is active, this link is blocked, and this is the ring master. If you need to expand your industrial network, build more complex topologies, and integrate with third-party networks, another redundancy protocol called Turbo Chain could be used. Turbo Chain is the semi-ring, and this is why it is so flexible. You can attach one or more chains to the backbone network, which runs Turbo Ring, RSTP, MSTP, or even another turbo chain, without interrupting the existing backbone network. To configure Turbo Chain, we need to assign rules to the switches: one head, one tail, and members in between. Head and tail are used to connect chain to the backbone, while tail port blocked by default as backup path. If a failure occurs, tail port will be unblocked to restore communication within 50 milliseconds. Let's configure Turbo Chain in our demo topology. I will use 3 Moxa EDS series DIN rail switches to form Turbo Chain and hook it to previously configured Turbo Ring. The rules need to be assigned accordingly, including head, member, and tail. Let's configure the switches from left to right. I'm logged into Web User Interface of EDS G4008. Configuration is located in the same submenu as other protocols, which is Network Redundancy, Layer 2 Redundancy, and Turbo Chain. Turbo Chain also needs to be enabled globally. Here is where we select chain rule for this particular switch and the ports that form the chain. I will set this switch as head and configure G3 as head port and G4 as member port. I'm repeating the same step on the second switch, which is EDS G4012. The difference is that I choose member rule and port 1 and 2 as the member port. The third switch, which is EDS 518E, has a slightly different web user interface, but the configuration steps are similar. In communication redundancy, Redundancy Protocol menu, select Turbo Chain as protocol. Configure this switch as tail, G2 as tail port, and G1 as member port. With all switches configured, let's connect the cables between them using member port and hook the entire chain to turbo ring with head and tail port. When you see head and tail LEDs in steady green, it means that the turbo chain is configured properly. This can also be checked in the web user interface. On the head switch, the head port and member port are both in forwarding state, and on the tail switch, the tail port is blocked. Coming back on MX View 1, this is how turbo chain looks. Head and tail switches are linked back to turbo ring, and the tail port is marked as dotted line. Turbo ring and turbo chain provide a comprehensive toolset for redundant network design. However, there are scenarios where equipment from different manufacturers should be connected into a single redundant ring with predictable recovery time. A standardized Media Redundancy Protocol is a suitable option for such cases. Its operation principles are similar to Turbo Ring version 2. It has one switch with the Media Redundancy Manager (MRM) rule, and the rest with the Media Redundancy Client rules. The manager blocks one of its ring ports and, in case of a failure, activates the backup path. There are several profiles in the standard that provide recovery time within 500, 200, 30, and even 10 milliseconds. So you have to check which recovery time is guaranteed by a particular device. This time, I will use two PT G7728 to form an MRP ring. These are modular rack-mount switches designed for power substations. Let's log into the top switch first, and then continue to configure the bottom one. Similar to the previous protocols, MRP is also located in the redundancy submenu and need to be globally enabled. We need to pick a rule between manager and client and select the redundant ports. You may notice that there are more parameters in MRP. The VLAN ID for MRP frames, domain identifier for different environments such as Profinet, and whether manager should react on a link change frame. Now, let's configure the second PT G7728 as client and choose the redundant port properly. After clicking Apply, we can proceed to wiring the topology. I will connect the cables to form MRP ring using the defined ring ports. As you can see on the front panel, the manager LED is in steady green, which indicates the ring manager rule. In the web user interface, you can check the rule of the switch and status of its ring ports. When one of the manager's port is blocked, MRP ring is healthy. And here are our switches in MX View 1. Now we have all three redundancy protocols in the same topology, ready for performance testing. Now I'm going to test the recovery time of Turbo Ring version 2, Turbo Chain, and MRP. I will use a special tool to send ICMP packets every millisecond and will count lost packets during network recovery. The tool is running on the industrial computer DA820C, and it pings my laptop. The network is healthy now. The ICMP packets go along this way to reach my laptop, and there are no packet loss. First, I'm going to unplug the active link in Turbo Ring version 2. The recovery time is 35 milliseconds, which is well within the guaranteed interval. MXV1 also indicates that the link went down, and the backup link became active. Next, I'll unplug the link between the two EDS G4000 series to break the turbo chain. The tail port goes into forwarding state and network recovers in 41 milliseconds. Finally, let's see the recovery time of MRP by unplugging the active link between two PT G7728. As you can see in the tool, recovery time is 49 milliseconds, which is a little bit longer than Turbo Ring and Turbo Chain, but still good for IED to SCADA communication. In today's video, I covered 3 redundancy protocols: Turbo Ring, Turbo Chain, and MRP. All of them can be used to build station bus networks that comply to IED to SCADA communication recovery time, suggested by IEC 61850-5. Both Turbo Ring and MRP are based on ring topology and have similar operation principles. While Turbo Ring guarantees less than 50 millisecond recovery time, it can only be built using Moxa switches. If you need to mix different vendors' products in a same ring, MRP is a good option. When you need a more complex topology than single ring, Turbo Chain provides easy and flexible expansion, and with less than 50 millisecond recovery time. If you want to know more about industrial network design or sign up for a training course to have hands-on learning experience, please don't hesitate to contact your local Moxa representatives. Thanks for watching. See you next time.